All right, calculus, welcome to your notes video for Tuesday, October 5th, when I am not with you. We're going to be getting into section 2.3 for a bit here. And first, we got some in-house sponsors. Yes, we have Zevia Black Cherry Soda, the 0-calorie soda. No sugar, all Zevia. If you want to be good at making friends, next time they ask for a Coke, give them a Zevia. Then we have Deerberg's brand electrolyte water. Not your regular water, folks. This bad boy's got electrolytes. Also, just arrived from Amazon, Noon Hydration Energy for an anytime recharge. And lastly, because the body is a what, Schneider? You got it, Temple. Your guess is as good as mine. Kinnick, who knows? Vanilla wafers. That's a lot of K's and N's. Gluten-free, free from nuts, gluten, soy, peanuts, dairy, almost everything. All right, folks, here we are. Section 2.2, we thank our, or 2.3, we thank our sponsors. Anyway, yesterday we should have looked at a graphical representation of limits, and we'll probably continue with that. I just want to sneak these notes in here, and we'll come back to these, of course. So we are going to solve limits algebraically for a lot of this chapter. So first off, we know that like 5 divided by 0, negative 3 divided by 0, that's undefined. But 0 divided by 0, that's what we're going to call indeterminate. And we're going to see that a lot this year, and that's sort of situation, folks, we just can't accept. We can't say undefined. We need to do a little bit more. Also, indeterminate, plus or minus infinity over infinity. All right, so if I have this example, and this is saying evaluate the limits of this function as x approaches 4. If I plugged 4 in for x, I would get 16 minus 8 over minus 8, which is 0, over 16 minus 28 plus 12, which is 0 again, 0 over 0 situation. So I can't just plug 4 in. I'm going to get 0 over 0, which tells me nothing. So what I'm going to do is I'm going to factor. What multiplies to 8 differs by 2. There it is. What multiplies to 12 and adds to a negative 7. There it is. Now, what do I notice here? I notice up top and down below, I've got this removable discontinuity, okay? Boom, x minus 4 gone. So now I have the limit as x goes to 4 of x plus 2 over x minus 3. And now I can let x finally be 4. Yes, you're going to have to keep writing the limit as x goes to 4 until the step where you finally plug 4 in for x. Yes, I will check that. Write that down. All right, so my answer is 6, and we'll look at that graphically as well. Looking at graphs while I'm trying to make one of these videos is not the best, so save those. We can use Desmos and write this function and see what's going on. But the left-hand limit and the right-hand limit, as we talked about yesterday, it's going to be 6. All right, take a look at 2. I want, again, pause this if you need to. The limit as x goes to 1 of x squared minus 1 over x minus 1. Again, plug 1 in, get 0 over 0 again. I'm not going to do that anymore. You should assume we're going to be simplifying or factoring. Some we won't have to, though. So I factor x squared minus 1. I get x plus 1, x minus 1 over x minus 1. Then what can happen? We can cancel. I have the limit as x goes to 1 of x plus 1. Now I can plug 1 in for x, which is 1 plus 1, 2. So the limit as x goes to 1 of this function is 2. Show that work. We're in good shape. Okay, so this is not necessary. I mean, sort of got a factor at the end here, but I got to clean this up. Again, if I plug 0 in for h, I get 9 minus 9, which is 0, divided by 0. Look at this. I have something with h, and now I'm finally going to let h go to 0. I was hinting at that a lot with the difference quotient. So here we go. The limit as h goes to 0 of, I got 9 plus 6h plus h squared. When I square that, minus 9. I don't know why I put this in parentheses. The 9s are going to cancel, so I have the limit as h goes to 0 of h squared plus 6h divided by h. I'm going to cancel an h, cancel that. It's h squared over h plus 6h over h, which is this. Now I can let h be 0, and I get 6. Evaluating limits algebraically is what we're about here. All right. Quick sponsor break. Zevia. None of the sugar, double the price. All right. Example 4. Limit as x goes to 3. 3 minus x over x squared minus 9. All right, so the x squared minus 9 has got to cancel factor because you're going to have 0 over 0. So I have the limit as x goes to 3 of 3 minus x over x minus 3 times x plus 3. These will cancel, and they'll cancel to be -1 because they're opposites. X minus 3 and 3 minus x are opposites. That's why I have -1. Up above, I can finally plug 3 in for x. I'm going to have -1 over 3 plus 3, which is 6. -1, 6. So we're going to see a lot of these types early on. These are the best ones to show to you for your first examples of evaluating limits. All right, then we have the limit as x goes to 5 of this quadratic. Well, folks, I can simply plug 5 in for x right away. And the left-hand limit and the right-hand limit are going to be the same. They're going to both converge to the same y value. Plug 5 in for x, and you get 39. All right, so I have 3 straight examples of functions. You can simply plug, the limit as x goes to blank, you can plug that blank in for x. All right. If I plug -2 in for x, sometimes you want to check too to make sure you don't get 0 over 0. If I plug -2 in for x, as I've done, now, yep, I didn't make a boo. All right. I get -1 11th. All right, so there are some, and on your first homework set for this chapter, which has 4 homework sets, goodness, you can plug numbers in for x on a few of them. So like example 7 here, the limit as x goes to -7 of this radical function. If I plug -7 in for x, I get the square root of 26. That'd be a good one that we can see graphically how this is working as well. Solving things algebraically is great because it just might be a pain to make some of these graphs. All right. And we get into our last 3 here. We're going to have 10 examples. You can pause this whenever. Next sponsor break. Noon. Berry Blast. Ginger Lime Zing. Tropical Punch. Watermelon Burst. When you want to make that water extra tasty and healthy. Example 8, the limit as x goes to 5 of 2x squared minus 50 over 5 minus x. I need a factor at the top. Take the 2 out first. Then it's the difference of 2 perfect squares as I have here. Again, x minus 5 and 5 minus x will cancel, be a -1. So 2 times -1 is a -2. Times x plus 5. Now I can finally plug 5 in for x again. Notice how I have the limit as x goes to 5, the limit as x goes to 5, the limit as x goes to 5, because I've yet to plug 5 in for x. Now I am. I get a -20. Let's go to example 9 here. Uh-oh, x squared minus 8. It's definitely not x minus 2 to the 3rd, all right? You hide that. Nope, nope, nope. We did not write that. Instead, go back to Algebra 2. This is a difference of 2 perfect cubes, so the cubed root of x to the 3rd is x. The cubed root of 8 is 2. Minus. Take that first term and you square it. It's always the opposite sign because you didn't have an x squared, nor did you have an x term, so it's got to be the opposite sign. You need the x squareds and the x's to cancel. It's the opposite sign, so plus the inner product is 2x. Then you take the second term. Think of it as 2 or -2, doesn't matter. It's, when you square, it's a +4. Look at that, the x minus 2's will cancel. Now I can plug 2 in for x. I get 12. Gonna see a lot of those. Those are very classic questions right now. We're gonna try to evaluate all the limits possible, all right? We're going to take a lot of time with that. And that's the good thing about taking calculus over the course of a year. We can do all the questions, all of them. So the limit as x goes to 0 of that function, again, if you plug 0 in for x, you're going to get 0 minus 0 over 0, which is 0 over 0, indeterminate. You can type in 0 over 0 in your calculator, and it's going to probably give the same sort of statement if you just divide by 0, but it's indeterminate. You need to go further. You need to do something else to figure out what's going on. All right, so I'm going to divide everything by x. Now I can plug 0 in for x, and I get a negative 3/4. All right, so we will continue with if we need to look at some more graphs in that packet I gave you yesterday. We'll do that, but we'll also pick up again with section 2.3 and evaluating some limits algebraically. All right, folks, this is the Math Videos signing out. I will have more information with your schedule when I see you again on Wednesday. Have a good rest of the day, and go Cardinals.